All right, we're taking a look at our study guide on trigonometric functions. This thing has 5 parts. I'm going to do a couple of problems in each part, and I'm going to try to set these up in chapters in the video. So if you need to refer, if you're struggling with one part and need to refer to that, you should be able to find it more easily in the video. So let's just jump in here. This first part is just talking about the main characteristics of periodic functions, and what we're talking about there is amplitude, midline, and period. So let's talk about what you would need to answer letter A here, and then do just a little bit of explanation. This is telling us we have a periodic function with a maximum value of 16, a minimum value of 4, and it's asking us, and a full cycle every 12 units, and it's asking us for amplitude, midline, and period. My suggestion here would be to do the midline first, to calculate that midline, which is just an average of the upper and lower bounds of the function. All we have to do is add together the maximum and the minimum and divide by 2. It's literally an average. So in this case, we have 20 divided by 2, or our midline is going to be at y equals 10, and that answers that part of the question. The amplitude is simply, I would use the upper level, the maximum, which is 16, subtract the midline, and we get an amplitude of 6. And that's all there is to that. And the period, which I'm going to denote with a capital T, is given to us at 12 units. 12 units. So that one's done. Now to explain some of that, let's just graph it here real quick. Now we're told that we have a period of 12. So I'm just going to put that 12 there, and then I'm just going to divide it up into 4 even slices to make the graphing a little bit easier. We're told that we have a maximum value at 16, and I'm just going to put a quick line up there. We're told that we have a minimum value at 4. Let's put a quick line right there. And we calculated our midline at 10, which is going to be literally in the middle of that. So that's at y equals 10. And that makes sense because the distance between 16 and 10 is 6. The distance between 10 and 4 is 6. So it is literally in the middle. And then if we want to graph this, we could start right here. We'd go up here, back down to the midline, down to the middle, or down to the minimum, and then back up to midline. And our graph would look something like that, where this distance is the amplitude. We've obviously got the midline here, and we've got the period identified here, and that's really all there is to that one. So let's take a look at this pendulum swing. We got a pendulum going furthest point to the left at a distance of -8, furthest to the right of 8, and it does so in exactly 3 seconds. So again, I would always kind of recommend a sketch here. A pendulum is just a string hanging, and it's going to swing left to right, and in this case, it's going to swing over to a value of -8. It's going to swing the other way to a value of 8. And it's going to make this swing, it said from furthest from -8 to 8 in 3 seconds. And we need to realize there that's only half the period. It needs to come all the way back. So the period is actually going to be 6 seconds. And if we look at this on a graph, and again, it's not necessarily mandatory that you use the graph, but I think it helps a little bit. Down here, we're going to have a value at -8. Up here, we'll have a value of 8. And we know we have a period of 6 seconds. And again, I'm just going to split that up into quarters so it's a little bit easier to draw. So I'll just put a line up here at the maximum value, a line down here at the minimum value. And if I start at the midline, well, then I'm going to go up to the max, back to the middle, down to the minimum, and then we're going to start all over again, and our periodic function would look something like that. So it's asking us for the period. Well, the period we said was 6 seconds. The amplitude we know is this distance. That distance is the amplitude. It's always a positive number, and it's going to be 8. The midline, in this case, we can calculate it as 8 plus -8 divided by 2, which is just 0. So we know our midline is at y equals 0. And then it asks for an explanation, of what each value physically represents. And you just go through and say, well, the period represents the amount of time it takes to swing from -8 to 8 and back again. Something like that. The amplitude is just representing how far the pendulum is swinging from the center. And the midline is the average value. It is, in fact, the resting position or the center of the pendulum. And that's really it for that one. Okay, so for part 2 here, I'm going to come down to number C, and we're going to convert negative 150 degrees into radians. And this just requires that we remember the conversion. And we can get the conversion from the unit circle. You're going to have that available to you. So the unit circle is pi radians is the equivalent of 180 degrees. And we just punch that through on our calculator, and we end up with negative 5 pi over 6. And then explain what is 1 radian. Well, 1 radian, we've talked about this in class. 1 radian, if I have a circle, and this is the radius of that circle. If you can imagine taking that radius, wrapping it around the circle 1 radius length, that is a radian. So how do I put that in words? It would be something like a portion of a circle with an arc length equal to the radius. Something like that. You're just talking about a portion of a circle defined by that arc, and that arc is equal to the length of the radius of the circle. Okay, moving down in part 2, we have a tire with a radius of 15 inches. So we just sketch a tire here real quick. We know we have a radius of 15 inches, and we know we're rotating through an angle of 11 pi over 4. So what does that really mean? Well, we know one trip around the circle is 2 pi. That's 2 pi. If we put that over a common denominator, that would be 8 pi over 4. And we're going 3 more, 3 pi over 4 more. So 1, 2, 3. So we're going to right here on the circle. So what we're really doing is starting at this point. We're going all the way around the circle, and then we're going to there. But honestly, none of that really matters, because all you need to do is take that angle, 11 pi over 4, and multiply it by the radius of the circle. And we're going to leave that in terms of pi, and it's going to end up being 41.25 pi. And it is important that you leave it in terms of pi, because it says exact linear distance here. Okay, let's keep going. Okay, so moving on to part 3, these first 2 questions, A and B, you're going to see one of the 2 of them, and the answers are exactly the same. So let's just make sure we understand this. If we look at the sine wave, just going to make a sketch real quick. So we're going to come out here. We're going to divide that into 4s. We're going to start here and here and here and here and here. And that's kind of what a sine wave looks like, with this value being 1 and this value being -1. So this is f of x equals the sine of x, parent function for a sine function. So what's the period? The period of a sine wave is 2 pi. It's one trip around the unit circle. The amplitude is right here. The amplitude is always going to be 1. The midline is the x-axis. So the midline is going to be y equals 0. The domain of a sine function or a cosine function is going to be all real numbers. And finally, the range of the function. The range of the function is the maximum and minimum values. So the minimum value here is -1. The maximum value is 1. So we would write the range as -1 to 1. And that's it for that one. So let's talk about letter G here. It says, using the definition of a unit circle, explain algebraically and conceptually why the range of y equals sine of x is limited to -1 to 1, which, by the way, gives you part of the answer for letter A up there. And if we take a look at a unit circle, we know that the radius of a unit circle is 1 unit. That's where the unit comes from. And so the reason we're limited from -1 to 1 is if we look at these values out here, this is going to be 1, 0. This value up here is going to be 0, 1. Over here, we are at -1, 0. Down here, we are at 0, -1. And the point of all that is we're trapped within this radius of 1. No matter where we go, we can only go from 1 to -1, back to 0, back to 1. The function is going to oscillate between 1 and -1 forever. So any words to that effect, that ties it to the unit circle, saying that the radius of the unit circle is 1, And so we are tied to oscillating between 1 and -1 forever. That's all that's looking for there. Okay, so for transformations, let's go down and look at letter F here. What we're looking for is amplitude, period, midline, and domain. So if we remember our basic function, we have a times the sine of b times x minus c plus d. So we know that this a value, the absolute value of that a value, defines the domain. So right here, we've got an a value of -4. Did I say domain? I think I meant amplitude. We know that the amplitude is equal to 4, the absolute value of -4. So that takes care of amplitude. The period of a function is going to be equal to the parent function period, which is 2 pi, divided by the absolute value of b. So for this function, we have a b value, it's 1/2. So to calculate the period for this one, we're going to have to take 2 pi divided by 1/2. And to do that math, we'll have to employ keep, change, flip. We're going to keep the numerator, change from division to multiplication, and flip the denominator. And we're just going to end up with a value of 4 pi. So the period here is equal to 4 pi. So we've taken care of that. The midline is given to us in this value, +7. That is the value that moves the function up and down on the y-axis. So all we have to be able to do there is read the function. That is the midline, y equals 7. And the domain of all sine functions, unless we limit the domain for some reason, is all real numbers. That's the entire nature of a periodic function, is that it goes on forever in both directions. Okay, I want to take a look at letter H here, but I'm going to bring up Desmos to do that. Okay, so for letter H, I've already typed in the function. One problem I saw with a couple of students that I was helping this on, if you go back, if you type in the function and look at it around the origin, you can't see it. You need to realize we've added 65 to this thing, so it's actually way up here. So you just need to find it on the graph. And the only thing this is asking is, after midnight, what is the maximum depth and at what time did that occur? So midnight is right there. The first time after midnight that we reach the maximum depth is right there, and that's 4 hours after midnight, and the problem defines H as hours. That's the x-axis, so 4 is 4 hours after midnight, and the maximum temperature reached is 77. So really, this is just an exercise in putting the function into Desmos and properly interpreting the graph. In this case, the maximum temperature was 77 degrees, and the first time it happened was 4 hours after midnight. And that's really all there is to that one. For the tangent function, let's take a look at letter C. The main thing we need to remember for this section, and we'll do a little bit more on tangent in the next unit, but we need to remember that the tangent of an angle is equal to the sine of that angle divided by the cosine. So in this case, we're trying to define the tangent at 2 pi over 3. Well, that's going to be equal to the sine at 2 pi over 3 divided by the cosine at 2 pi over 3. The sine at 2 pi over 3 is √3 over 2. The cosine at 2 pi over 3 is -1/2. Now at this point, we just need to remember again, keep, change, flip. We keep the numerator. We change the operator from division to multiplication, and we flip the denominator. So we have -2 over 1. And then we just multiply across. So we have -2 square root of 3 divided by 2. We can further simplify that. 2 over 2 is 1, and we end up with the negative square root of 3. That's all there is to that one. That one's really just an exercise in dividing fractions. And for letters E and F, we talked about these a little bit in class. There is a point for tangent that is undefined, and the reason for that is we can't divide by 0. So if, for example, you looked at the tangent at pi over 2, well, the sine at pi over 2 is 1, the cosine at pi over 2 is 0, and we can't do that. We cannot divide by 0, so that function at that point is undefined. And in terms of, it says explain algebraically, this is the explanation algebraically. You identify that it's division by 0 and that operation is undefined. You've explained it algebraically. Okay, and that's about it for the study guide. I'll post the study guide and all the answers to the study guide along with this video, which provides a little bit of explanation. I hope that's helpful. Please make sure you can do all of these. We'll do our assessment on this topic on Monday. And remember, there's still one more seminar this afternoon, so if you have any questions, come by and get them cleared up. All right, good luck. I'll see you in class on Monday.